Hello engineers, welcome to the 48th video in learning MOSFETs through shorts, and in this particular video we are going to learn a new concept based upon a MOSFET, and that is known as a diode connected MOSFET. So here what we want is that a MOSFET, it should act as a diode. So we can clearly see that a diode is a two-terminal device, whereas a MOSFET, it is a three-terminal device. So we need to convert this three-terminal device into a two-terminal device. On top of that, this particular MOSFET, it should also act as a diode. So whenever I say that I want to convert a three-terminal device into a two-terminal device, so basically we need to short any two of the terminal. So we need to short either drain source terminal, gate source terminal, or gate drain terminal. So we'll go with the very first case, that is shorting drain and source terminal. So whenever we short drain and source terminal, so basically our VDS becomes 0, and as our VDS becomes 0, so my MOSFET, it won't be operated into the saturation region. So we neglect this particular case. In the next case, we short gate and source terminal, and when we do so, our gate source voltage, that becomes 0, which eventually becomes lesser than the threshold voltage, right? So this condition is not getting satisfied, and our MOSFET will always operate into the cutoff region, right? So we cannot short gate and source terminal as well. And the last what we have is this, that is shorting gate and drain terminal. So whenever we short gate and drain terminal, so we ensure that both of the condition is getting satisfied. That is, my gate source voltage, it is greater than the threshold voltage. As you can see, if my threshold voltage is 1 volt, source voltage is 0 volts, gate and drain voltage, they will be 5 volts as they both are shorted together, right? So VGS is 5 volts, which is greater than the threshold voltage, that is 1 volt, and VGS minus of VTH, it is 5 minus of 1, that is 4 volt, and your drain to source voltage, it is 5 volts, right? So my drain source voltage, it is greater than VGS minus of VTH, which was 4 volts, right? So both of this condition, they are getting satisfied, meaning is that here my MOSFET operates into the saturation region. Also we can convert it into a two-terminal device, plus it can act as a diode as well. So whenever I say that in this particular condition, this particular MOSFET acts as a diode, so it should exhibit this particular property. That means the current flowing through this particular diode, as we know, it increases exponentially. So we expect the same case from this particular MOSFET as well. That means a diode connected MOSFET. So we are going to verify this particular condition in the next video onto the LTSpice software. So if you are enjoying this kind of content, make sure to like, share and subscribe the channel. Thank you.